Hello viewers, in today's session let us solve this indefinite integral. So here we have to evaluate the integral x raised to 5 e raised to 3 times the natural log of x minus 3 raised to 4 times logarithm of x to the base 3, right? So here we'll see how we can easily find out the value of this indefinite integral using an important property of logarithms. So let us call this integral as I, right? And here we have natural log of x. So let us replace this notation, that is a natural log of x, by log x to the base e, because these two notations are equivalent. So we can now write this integral as integral x raised to 5, and here we have e raised to 3 times log of x to the base e, and then we have 3 raised to 4 times the logarithm of x to the base 3. Okay, so now here we can also make use of the power rule for logarithms, that is a log of a raised to, say, n is given by n times log of a. So here we can write 3 times log of x to the base 3 as log of x raised to 3, taking this 3 to the power of x, and here we have the base e. And similarly here we can write 4 times log of x to the base 3 as log of x, and we can take 4 to the power or the exponent, that is x raised to 4, and here we have the base 3. So now this integral I can be written as x raised to 5 and e raised to log x raised to 3 to the base e, and then we have 3 raised to log x raised to 4, and here we have the base 3. Okay, so now we have this expression. So now let us make use of another important property of logarithms, that is, say, m raised to log, say here we have the base m and here we have p. Then m raised to a logarithm of p to the base m is equal to p, where this quantity m is greater than 0 and m is not equal to 1, and obviously p should be greater than 0. So this property is going to be used to simplify this term and this term. So let us first apply this property to this term, and then we'll apply this property to this term. So here we have e raised to a log of x cube, and here we have the base e. So if we compare this expression with this one, then the value of m is e, and for p we have x cube. So this expression is equal to x cube, and similarly here we have 3 raised to log x raised to 4, and here we have the base 3. So if we compare this expression with this one, then the value of m is equal to 3 in this case, and for p we have x raised to 4. So the value of this expression is equal to x raised to 4. So now we have the integral I as integral x raised to 5 times x cube, and then we have minus 3 raised to logarithm of x raised to 4 to the base e, that is simply x raised to 4, and here we have dx. So now we have here 5 plus 3 8, using the laws of exponents, that is the base are same, so we can add the exponents. So we have x raised to 8. So here we have x raised to 8, then we have x raised to 4 and dx. Now we can simply integrate these two terms by using this rule, that is integral x raised to n dx is equal to x raised to n plus 1 over n plus 1, where n is not equal to minus 1. So here in the first case we have the value of n as 8. So we have x raised to 8 plus 1 over 8 plus 1. Then here we have in the second term x raised to 4. So the value of n is 4. So we have 4 plus 1 over 4 plus 1, and c is the constant of integration, because in indefinite integrals we take the constant of integration. So now this is x raised to 9 over 9 minus x raised to 5 over 5 plus c. So the value of this indefinite integral I is given by x raised to 9 over 9 minus x raised to 5 over 5 plus c, where c is the constant of integration. So this is how by making use of this property we can evaluate these kind of indefinite integrals.